Welcome! In this episode, we're going to take a look at the async await functionality that we get in ES7. Are you tired of code that looks like this? Just look at the depth of that callback pyramid. Well, you might be thinking to yourself, Hendrik, what are you on about? We don't need to code like this, we've got promises to help us. I really don't think this is much better. And this is using promises. Promises are super useful, but where they break down is when you need to compose them, especially when you want to do something based on a result of 3 promises up in the chain, or if you want to do something conditional. Promises aren't going anywhere, because as I'll show you soon enough, they're in fact required even with async await. But where we'll derive benefit from async await is when we want to make our code more readable, when we want to sequence promises and add conditional logic. Meaning conditional calls to async functionality. ES7 features are still subject to change and is not supported by most JavaScript environments. But luckily, we can use Babel. Babel is a transpiling tool that takes ES7, ES6 and even JSX and transpiles that to ES5 JavaScript, which will run in all semi-modern JS environments. Before we can get started, we'll install Babel Node, which is a command line utility that transpiles and then executes the result with Node. It's just the easiest way to get going with Babel in my opinion, but usually you would call Babel as a build step using Grunt, Gulp, or even Webpack. It comes in the form of an npm package, so we install it on the command line. Now that we've got that out of the way, let's code up some async logic using promises first, then I'll show you how to refactor that to use async await a bit later on. We first create the directory async await and cd into it. Let's open this directory and add some along. Okay, so because we want to use bleeding edge features, we need to tell Babel that we want to do so. To configure Babel, we can create a Babel rc file. So just in the root of your project, create a file .babelrc. And in here, we want to specify a JSON object with a property called stage and a value of 0. This tells Babel that we're fine with ultra bleeding edge features. For this video, we're just going to code up everything in a single file to keep it simple. So we create a script.js file. For the async code, we're going to consume the GitHub API. And I want to do this with the awesome fetch API. Because this is a Node environment, I need to install a package for fetch. Back on the command line, I install a package called node fetch. npm I node-fetch. Okay, great. Let's use this library in our code now. The fetch API in itself is promise-based, so it will work well for our purpose. At the top, we import the fetch object from the node fetch module. Let me type out the URLs we're going to be calling using fetch as comments over here to give you an idea. First, we're going to call the user's endpoint to get the profile information. This last field here is the username, so I'm just passing mine in there. Let's duplicate that line. The next route we're going to consume is to get repos for a user, and for that, I just need to append repos at the end here. Still with me? Okay, just checking. Now let's define the username as a const here and assign it to my username. And now let's define a function called getProfile. And in here, we return the result of calling fetch on this URL that conforms to the user URL up here. And we use the string template syntax so that we can wrap this variable into it. If this looks strange to you, go have a look at the ES6 videos on tag tree to learn some ES6 features. This function just returns the promise that we got by calling the fetch function. Let's duplicate this function so that we can make the other call from the new function. We rename this function to getRepos and adapt the URL here to conform to what we've got up here in the comments. To consume these promises, we call getProfile first and chain it then onto it. Now the fetch API resolves a response object as a result of calling fetch, which contains a whole bunch of information about the response like the HTTP status code, response headers, and the like. You have to pass that from JSON into an object if that's what you expect. So we add a callback function using the arrow function syntax. And we specify that we want this function to return the profile response as JSON. The response object resolved by the fetch promise has a function called JSON on it, which returns another promise. So we just return that and add another then onto the chain. Because we asked it to parse it as JSON, we can now expect an object literal containing our profile. Now, for this demo, we want to combine the profile object and the repos object into one object. So I need to kick off a call to get repos. But because we don't want to lose this profile object we've got available on scope here, we're going to add a then onto this promise in here itself, so that we can use a closure to get access to this variable up here. So now we're getting into pretty nasty territory here, because we're going to nest promises, which is not a good thing at all. A better pattern to follow here would be to have what is called a shallow promise chain, meaning no nesting of promises at all. The way to do that is to define an object before this code here and use that as a context that each link in the promise chain adds to. But it's just too darn tempting to nest it here, and I've seen so many people do it this way. Plus, it will just make the difference between promises and async await so much clearer. Anyway, I digress. In this then, we do the same than what we did with the profile response. We turn it into an object literal by calling JSON on it. And now we chain another then on here. At this point, we've got access to the profile object from here and the repos object from here. So it's time for us to return the combined object. And we use this ES6 literal shorthand syntax to construct it. This code will just use the name of these variables as the attribute names on the object that it creates. So we've created a promise chain that will combine the result of the two objects. In the end of this chain, we added another then on it. And here we can expect a combined object. Let's just log that out to the console. Console log combined. And now we also want to add some error handling. Nothing worse than an error happening but not displayed. Okay, lots of things are worse than that, but it's still pretty bad. Let's run that. So on the command line we type Babel node and pass it the script. Okay, we've got valid data coming back. So this is pretty ugly, isn't it? It's pretty hard to follow what's going on here, and all we really wanted to do was make one call, then the other, and add it to an object and log it out. This is pretty bad. Let's fix it. Let's get rid of all this code we've done so far. So as you might have seen, this is the basic syntax for async await. You've got a function preceded by the async keyword, and you can call it by using the await keyword. And the JavaScript engine will resume your code only once this async function returns a result. What's interesting is that you can also wait on a promise. This is what I was talking about earlier on in this video. Promises are still required, even with async await. But we don't need to resolve them when we want to use them as we do now. Now we can just await on it, and when it gets resolved, the next line gets executed. This is a super useful approach because most libraries these days are promise-based. And if you're using one that isn't, you can easily wrap the library's functions as promises. Okay, so let's do this in our code. So you might be tempted, as I was when I first played around with async functions, to do something like this. Call the promise, which is interchangeable with an async function, like this, by just adding an await in front of it. So profile equals await, get profile. Let me actually run that so you can see what error we get back. See here in the output, Babel is telling us that it didn't expect this over here. It's getting confused by our await that we added. And when you read up on it, you'll find that you can only await on async functions from within other async functions. This confounded me when I ran into it the first time. Under the hood, async functions work exactly like generators and yield. So it needs to happen inside of a context that can unload. It makes sense to me at least. Hit me up on the chat channel on this page if you want to talk about that weird statement a bit more. Okay, so let's define an async function, shall we? We define it like any other function, but prefix it with the async keyword. In this case, let's call it getCombined and move this line into this function. We're going to flesh this function out a bit more soon enough. But for now, let's see what happens when we call this. So await getCombined. This won't work, so I don't even do anything with the result yet. Now when we run this in the command line, you can see that we get the same error. Well, yeah, of course, we're still not calling it from within an async function. To call this function from within an async function, we're going to do something that looks suspiciously like old school JavaScript namespacing before we add ES6 modules. We create yet another async function, this time an anonymous one. This time though, we do something different. We wrap this function like this, so that we can immediately call it. See what I mean with it looks like namespacing? We're setting up an anonymous async function and calling it immediately, ensuring that all our code executes within an async function context, allowing all our awaits to work. If you've played around with the Co library, which uses ES6 generator functions to help combat callback pyramids, this should look very familiar to you. Let's try that out in the command line. Success! We're not getting any error messages anymore. So let's finish off this code now that we've got the basic structure in place. In our getCombined function, we still need to take this response that we got from the profile and call JSON on it to pass the body as JSON into an object. First, let's rename this variable to profile response, just as we did with the promise earlier, because fetch returns a response object which contains a lot of extra info like the response code and headers. And now we assign profile to the result of awaiting the promise that results from calling JSON on the response object. We do the same with the repos call. First assign repos response to the result of awaiting on the get repos promise. Repos response equals await get repos. And now we assign a variable repos to the result of awaiting the promise we get by calling the JSON function on this response object. And now we can simply return the combination here by using the enhanced literal syntax again, an object composed of the repos and profile object. And simply log that out to the console. Let's run that in the command line. And it works! What I like about this code is that you can read it left to right, top to bottom. There's no chaining, no nesting or any such crap, just plain old readable code. But didn't we have a catch on our promise, so we could handle errors and log it out to the console? See what I mean? Here we've got a catch so that we could handle errors. How do we do that using all this async await magic? It's actually quite easy. All we need to do is to wrap this code here with, wait for it, a normal good old try block. Imagine that. And then add a catch statement after that. And then we just log this error out to the console. Let's force an error by changing the call up here to JSOP instead of JSON. Now when we run it, we get our error. And that, folks, is why I like async await. It makes asynchronous JS coding accessible to us mere mortals. And it allows us to focus on delivering real value instead of debating endlessly on promise patterns. I'm so over that. That's it for this episode. Bye.